I'm here on an intermittent problem with a Goodman condensing furnace in an attic. This furnace trips out every now and then. It does it usually when it's cold outside, but I know that it's not doing it because water is freezing, because first of all the lines are insulated, they're properly pitched, but also it does it when it's in the low 40s, so water does not freeze in the low 40s. When I open the panel, I hear water gurgling inside the inducer housing. That only means one thing, that the furnace is not draining properly, and water is backing up into that housing. It's not draining out of that drain line, it's backing up into that housing, and eventually it's going to cause a pressure switch to trip out. That gurgling sound is the sound of the fan paddling that water. That's not normal. When we hear that, don't ignore it, look into it further. So one thing that I noticed is that the ductwork is very restrictive. As you can see, there's flex going everywhere. There's a lot of friction in that ductwork, and that creates a very high supply static pressure. When I read the static pressure, it was well over ½ an inch on the supply side alone. Now, I hear a lot of technicians say that you don't need to put a trap on your case coil if it's on the supply side of the fan. That's simply not true. Not only is it required by the manufacturer, but a trap prevents you from wasting conditioned air. It also does something else when you hook it in conjunction with a condensing furnace. It prevents that supply static pressure from pushing air through the drain line and preventing your furnace from draining correctly. So that's what's happening here, is that air pressure is backing up and pushing against the drain line coming out of the furnace. That's preventing the furnace from draining into this common drain. So what's our fix? Well, we need to start at the source. That ductwork needs to get fixed. We need to get that supply static pressure down. But we may not be able to do that completely because a lot of that ductwork is not accessible. It's in between the floors. So then the next thing that we need to do is make that condensate trap a lot deeper, just in case we can't fix all the ductwork and make the supply static pressure a lot lower. That condensate trap needs to be deeper so it can handle the static pressure that's on the system. And finally, we need to install a vent there downstream so that air pressure has somewhere to go instead of taking the path of least resistance and backing up into the furnace. So when you're installing a condensing furnace with an air conditioning, the best way to do it is to run two separate drain lines, but you don't always have that option on a changeout. So sometimes you just have one common drain and you need to make it work. The manufacturer will give you some guidelines about how to tie those two systems in. Always use a deep enough P-trap. You always want to vent it. You want to tie the furnace into the main drain where they tell you to do so, so that these two systems can work independently of each other and not affect each other's draining. Now let's take another look at how these P-traps are constructed. So here we have one of those ready-made P-traps that you get from the supply house, and I've marked it where during the off cycle where the water is going to sit. It's going to sit right here where that top line is. If the water gets any higher, it's just going to drain out. Now when the blower comes on, that static pressure is going to push down on that trap. So if you have ½ an inch of static pressure, it's going to push that water column down ½ an inch on the P-trap. That's just how it works. As you can see, if we go any farther down than ½ an inch, we start losing our trap. There's a little pathway for air to escape. The higher static pressure is, the farther down that water level is going to go, creating a bigger air gap. So ½ an inch of static is the absolute max supply static pressure this P-trap can handle. Well, if you put that on a system with a higher supply static than ½ an inch, you're going to have draining problems. You're going to be pushing out the drain. These definitely should not be used on a commercial system with a higher supply static pressure. The same would happen if this P-trap was installed on the return side of the blower. Look, pressure works both ways. If you have a heat pump fan coil unit where the drain connection is on the return side of the blower, if you have more than ½ an inch of return static pressure, it's just going to pull that water column up ½ an inch, create an air gap, and not allow you to drain correctly. So always take a look at your P-traps, have good static pressure. If you need to custom make one that's a little deeper to suit your application, that's a lot better than using one of these ready-made ones that are never going to do their job. I hope you enjoyed the video. Please stay safe out there.